morning, everyone. Basically, we are from group number 3. We want to present on what we had learned and what we had done on this semester in this course. This course is basically is PLC. We can call it as PLC, and PLC stands for Programmable Logic Control, BNE 22103. And our lecturer is Jack Sumaya. So first of all, I want to introduce myself. This is me, and my name is Nian Sen Xiang. I come from Cebu, Sarawak, and this is my email, and this one is my phone number. For the task distribution, me as a good leader, and I'm going to do the task distribution, and I will going to explain the activities from week 11 to week 14, and I will explain the most difficult topic to me in this PLC course, and then I will try to solve the technical problem by using different methods such as ladder diagram, using process sequence, and etc. And I will do the small mind map for the all activities in this semester. This one is my members. He is Leonard Avolaini, and he also come from Sarawak. This his email, and this one is his phone number. Basically, he will do for the discussion about the objective for this presentation, and he will explain the safety and healthy precaution while creating ladder diagram, and he will explain the activities from week 1 to week 4 and the most difficult topic to him in this course. And this one is also my members. His name is Wan Muhammad Hazim, and he's come from Kota Baru, Kelantan. And this one is his email and his phone number. Basically, he will explain the activities from week 5 to week 10. He will explain how to transfer script when we have enroll in the PLC programming. And third, he will explain the most difficult topic that he have faced in this PLC course. And last, he will make a conclusion for this course. And this one is the my method which I have done to summarize all the activity in week 14. Basically, week 1 to week 14, I have made a summary on that. You can see right. Okay, you can read by yourself, and I will pass my mic to my member to explain.
The objective is to provide great accessibility towards user and to reduce the amount of time waste and human resource consumption in daily routine. For safety and health precaution, when disposing of this product, treat it as industrial waste. Make sure all the external load connected to output does not exceed the rating of output module, and only use it in an environment that meets the general specification. In week 1, we have joined the webinar Industrial Talk by Festo Didaktik. And the topic of this talk is PLC, pneumatic and hydraulic application in the industry. Introduction to PLC. PLC is an industrial control computer system that continuously monitors the state of input device, then process the input via custom program, and the output is used to control the device. And the application of pneumatic is used in industrial robots, also used in material handling types of equipment and logic controlling equipment, and also used for braking system in automobile. An example of pneumatic system is a compressor, air brakes, and HVAC control system. In week 2 is we discuss on the lesson plan, go through the previous semester PLC course activities, which is programmable HMI touchscreen LCD, wiring, Mento-Menti program, PLC application, PLC connection to hardware, and also watch PLC video presentation from the previous semester. In week 3, we studied chapter 1, the definition of PLC, which is industrial digital computer used for industrial automation, and application of PLC in the industry, such as oil and gas pipeline transportation, smart factory, and others. PLC system, power supply, memory unit, CPU, programming device, input device, output device. PLC receives data from input device, process the data, and triggers the output based on pre-programmed parameters. The operation of PLC consists of 4 stages, which is self-test, input scan, logic scan, and output scan, which repeated 10 to 100 times per second. I/O memory reference, which can be referred in the help menu in CX Programmer. Same with instruction reference. At the end of the lesson, students should be familiar with the Omron CP series and understand the features of these models. In week 4, we discuss pre-lab activity, familiarization with PLC Omron CP series. We identify PLC model number based on model number structure, which divide into class, I/O capacity, unit type, built-in port, input type, PLC output type, and power supply. We also identified the external interface for CPU and identified the different features of the models. Then illustrate the system configuration of the models and understanding the output and output bit for 20 I/O points.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, today I will present about week 5. So, in this week, we learn about chapter 3, which is PSC programming. So, in this chapter 3, we have a ladder diagram, which function is used to document industrial control logic system. Second one is rung, and horizontal lines that represents control circuit. Third one is bus bar power supply. Two vertical power supply, left which is 24 volt and right is 0 volt. And the setting for PSC is used is Omron CPU1E and E20 CPU type. And for address, input 0.00 to 0.11. For the output, 100.00 to 100.1.07. And the third one is internal relay, except 0 and 100. Okay, this is the basic ladder logic instruction. We have the ladder symbol, the title of each symbol, its type, and its description. This is how we learn to write mnemonic code based on the ladder diagram. We can see this is a normally open contact. So the address is 0.00. So its mnemonic code is LD 0.00. And this one is a normally closed contact, which is LD naught. So its mnemonic code is LD naught 0.01. Thus, so you can refer the next example. This is the next example for each type of ladder diagram. This is a parallel connection, OR and OR not. So this is a basic logic function. These are the example for basic logic function. Number 1 is AND, number 2 OR, number 3 NOT, number 4 NONE, number 5 NOR, and number 6 XOR. And next, in week 6, students must give response as a proof of absence in class session. If not, it is considered as absent. In week 6, we also study of Boolean expression with some case study examples such as float sensor application, latch push button application, traffic light application, car application, and machine application. Next, students must solve the solution given in the individual assignment. Those who did not submit will get 0 marks. And there is a discussion about simulation case study. For week 7, it is about explanation about PLC instruction content, such as cycle of program development, ladder logic structure, typical mistake, and activities. In week 7, we also have test 1 is held before the mid-semester break. This is the content in week 7, the cycle of program development. Number 1, writing and editing. All programming tools have one or more editors. These are user interfaces where the program writer constructs the program code. This can be a simple editor without graphical symbols and tools, or it can be an editor that is equipped with programming in a graphical language. This is the symbol of normally open and normally closed. This is also the symbol of parallel connection, or normally open and normally closed. And this symbol is for the coil, and this one is for the instruction. So this is the example of a ladder diagram in PLC programming Omron CP1E. Number 2, compiling and linking. Compiler is the program that converts source code to machine code, which is the code digital equipment such as PLC understands and can process. If the source code contains errors as a result of violation of the rules, it generates error messages in the compiler. Such errors that be found by the compiler are called syntax error. Examples of this syntax error are lack of declaration of variables or calling a function or subroutine that does not exist. Common to all syntax errors is that they make it impossible for the CPU to execute the compiled code and is therefore necessary to edit the code in order to remove such errors. Okay, next, this is the example of syntax errors. We can see that the PLC model have one error, zero warnings. And we can see that the programs have been checked with the program check option set to unit version 1.3. We can also check the error. For this one, error element at rung 0 is not connected at its output. For this one, we can check the error rung 0 overlapping rungs. So we can do the correction properly and correctly. Number 3 is uploading and running. When the code is free from the syntax error so that it can be compiled, the machine code can be loaded into the PLC for running. Note that many programming contain simulators so that the user can test the code without loading it into the PLC. This is the CX Simulator Debug Console. The next one is debugging. Most of the development tools for PLCs contain a tool for troubleshooting the code. Programmers usually use the word debugging instead of the troubleshooting, and such error finding tools are called debuggers. Debugging a program involves hunting for and correcting errors. And for the week 8, students have their mid-semester break. And for week 9 and 10, students must form a group for the group assignment. A group of students must create a system based on the PLC programming by using the CX programmer. Technical report and video presentation also included in this.
Now I would like to explain on the activity that we had done from week 11 to week 14. So basically for week 11 is an industry talk that and the experience sharing from two panel. This is the panel number 1 and panel number 2. For this talk, we need to make a short summary based on the talk, and this talk is on 8 p.m. to 10:15 p.m. by using Zoom. So basically, this is what I have made a summary for the talk. So for the panel 1, is he gives us advice that we need to understand the concept of the task given from the customer first, then we can process to design the program. If we don't understand the task given by customer, we cannot do the program because we maybe can make a lot of mistakes in the program. So basically from the panel 2, she said that the ladder diagram is more easy to start a PLC design. And she said that we can learn self-learning through the media like YouTube, Google, or online apps. If we have some problem or we have some does not understand, we can go through like media. We can go for search on YouTube to see the video or the Google for the better explanation. So for week 12, we have self-learning on this few topic. So basically, I have learned how to create a process sequence decision. What is process sequence decision? For example, simple narrative, motion diagram, and graph chart. So besides this, I have learned the latching circuit and the interlocking. So basically, this is one example of the simple narrative. As we can see, the simple narrative is table in table form. So this is for the input, and this one is for the output, and this is for the step. For step number 1, when start button is pressed, the motor will start running, and the green lamp will turn on like this. Okay, and this is the example of the motion diagram. As we can see, the input is at the above, and the output is at the below, and this will flow like this. For start, to motor start run, indicator on, and the sensor detect, and the motor stop to run, and the indicator off. Is such like this. And the third one is graph chart. Is basically this one is for the input. When we start, and we have input, start button, and after that we have output, and we have input again, we have output, we have input, output, and at the end. So basically the latching circuit. Latching is a electro logic circuit that has 2 input and 1 output. For the 2 input, is one is called set and one is called reset. So basically this for the diagram. For the latching, is used to maintain the high value of the input. So basically without this latching, if we press start button and release, the system will stop. If with the latching, if we press the start button and release, the system will continue to run because of the latching. We will maintain the high value. Okay. And besides this, we have self-learning about the PLC's CP1E trainer circuit. Basically, this is a CP1E trainer with the HTML. HTML is this: we can touch screen to press the input or to press the input. So basically, this is for the input switch control. And if we press this one down, this one is external, means that they have a external hardware connect to this trainer kit, and this middle one is for the external connection hardware, and this one is for the external output connection. And basically they have four common port for the output at here. There is output number 1, common port 1, common port 2, common port 3, and common port 4. And basically, as we can see, this is the CP1E, and we can see the border line here. They will separate each COM, and they have a total of 4 COM. Basically, the COM1 is control the 100.00, and COM2 will control 100.01, and the third one is will control the 100.02 and 100.03, and the fourth one is from 100.04 to 100.07. So basically, the week 13 we have the record of the whole semester activities is given by the lecturer, and we have a Google Meet with lecturer to discuss how we do our presentation. So week 14, basically we learn about some instruction like timer and counter, and we have our test tool in week 14. So basically, I will explain this in detail when I use the example tool for motion diagram. For as we can see, the motion diagram, the above one is input and the below one is output. As the sequence will be like this: the start button is pressed, the motor will run, and timer will start to activate. After 20 seconds, the motor 2 will run. And for the stop button, when stop button is pressed, the system will reset off. So now I would like to show how to create a ladder diagram by using ladder CS programming. So basically, we need to press your system name, and we go find the CP1E, and we check. We need to 20 IO point. So we press OK. If you don't know how to use the CS programming, you can go help and go find your address. And as we can see, we use the CP1E and we can find it here. Then we using the 20 IO point. So basically we find the 20 IO point. This for the input address. As we can see, the 20 IO point, we have 12 input and 8 output. So basically the input address will be from 0.00 to 0.11, and the output address will be here. We find 20 IO point, and it is from 100.00 to 100.007. So we can see that the timer here, we can use the address from 0 to 255, and the counter also will be 0 to 255. So go back. So if you did not understand for the instruction, we can go here, the instruction reference, and go find CP1E. You can see the keep instruction and counter instruction and the timer instruction. You can read here. Basically, the counter have two input address. One is set, one is reset. So basically, when we use the counter, we need to have a set input to the counter, and the set input must on and off so that the counter will count the how many times you do for your operation. So for the timer also have one input only. Basically timer is used to count the time. Okay, so I will now to the example on this question. As we can see, our input is start push button. The address is 0.00 and the stop button is 0.01, and the model 1 is 100.00 and the model 2 is 100.01, and our timer is 0.8010. So basically the first thing we need to create you can press the C to create the start button. Start. So it's our start push button, and output is 0.0 model 1. Is for the we need a latching for it. This one, model 1. Arrow to the start button, and basically the stop button will normally is the lock knob, and 0.01 for the stop. Is for to start the system, to start and to stop. So this one is for the timer. So basically we need to count for 20 seconds. So we have latching here again. So 0.00 model 1 will go to the timer. Type time, and our address is 101 and hashtag 200. Basically this time is for the millisecond, so we need to change for millisecond to second. Okay, timer. And step number 3 is for the timer T010 timers, and our output is 0.1 for the model 2. Yeah, our ladder diagram is not. So basically we can check for whether there is an error or in our program. So we can go to complete it first. as you can see, the program is 0 error and 0 warning. This means our program can start to work now. Okay, 0 error, 0 warning. When we go back to the question, when start button is pressed, motor 1 will start to operate. So we can check when start button is pressed, the motor 1 will start to operate. This is correct. And after 20 seconds, motor 2 will start to operate. This count for 20 seconds. Okay, then the motor 2 will start to operate. We can see here. And after 20 seconds, the motor 2 will operate. It's correct. And the third one is when stop push button is pressed, all the motor will start to functioning. So when this value is high, yeah, we are correct again. The two motor will stop to functioning as well. So we can check here when we press the start button again, and with the percent of latching, they will maintain the high value of the system. So basically, this is all the process how we create the ladder diagram by using the CS programming. Okay, that's all for me. Thank you.
Okay, for the trouble error, I will pick the most common mistake that students do. So, number 1, two normally open contact switches is used to control the circuit. If at least one of the switches is turned on, a motor should start. Usually, students draw this wrong ladder diagram. You can see this wrong ladder diagram at the bottom. So, a conflict between the rungs since use the same address on two coils in the program. We can see here at we can see that they have 0 errors but 2 warnings. So the correction, we change it into a parallel or an OR circuit. So either one of the switch is true, motor also in true state. Both switch is true, so the output is also true. This is the ladder diagram we should do. So we can see that there is no errors and warnings. So in my opinion, the most difficult topics is chapter 3, which is about how to transfer the program from PC to FPRC and hardware connection installment. So I suggest is we have to make hands-on activities or face-to-face lab session. That's all.
And the most difficult topic for me is chapter 3, which is PLC instruction. And the part that is difficult are online editing and writing, and trouble error, the ladder diagram. And the suggestion is to master the basic concept of ladder diagram.
And the most difficult part in this course for me is, I think, is to analyze the question, because analyze the question is very important when we start a program. If we did not analyze correctly or we analyze wrongly, they will affect the program. Okay? So basically, I will demonstrate how to analyze the questions. So this is our question. When start push button is pressed, motor 1 is start operation. After 20 seconds, motor 2 will start to operate. When stop push button is pressed, all the motor will stop functioning. So basically, first we need to find the input. What is the input of this program and output for this program? As we can see, the start push button is for the input and the stop push button is input. So we can make a small table or just write like this, and we can give them a address. As we know, the CP1E that has 12 input address and 8 output address. So basically, the input address is start from 0.00 to 0.07, and the output address is start from 100.00 to 100. Sorry, the input address is 0.00 to 0.11, and the output address is 100.00 to 100.07. So basically, we have two output for this question. This is model 1 and model 2. And be careful that the question has requested after 20 seconds, motor will start to operate. That means we need instructions like timer to control the time. So basically, we can make a process sequence decision first before we go to the ladder diagram. So basically, I make some example by using different process sequence decision. For example, one is I use the simple narrative. Basically, as we know, this one is for the step, and this is for the input, and this one is for the output. For the first step, start push button is pressed. Motor 1 will start running. Motor 1 will start running. After 20 seconds, the motor 2 will start to operate. So basically, when start button is pressed, motor 1 is start running, and the timer will start to count for 20 seconds. So step number 2, after 20 seconds, when timer is counted complete, and the motor 2 will start running. So step number 3, when stop push button is pressed, the system will stop. Okay, so this is for the example of the simple motion. Example of the motion diagram. So basically, the input is above and below is output. So basically, we have to start the push button, and the motor 1 will run, and the timer will start to count.
So lastly, the conclusion. The PLC is popular to be known as the controller that is very durable and reliable. Because of this, most traffic light uses PLC as a controller. As conclusion, PLC applications are typically highly customized systems. PLC is low compared to the cost of a specific custom-built controller design. In general, PLCs are more tough and require less maintenance, thus making the things they control work better despite the environment. The videos given to the students is very detailed and specified so that the students can understand the concept of PLC and the ladder diagram. Lastly, the PLC programs that have been designed are more systematic and short-term, which make it easier to upgrade the project for future need. That's all from me. Thank you.